Solar flare. The most powerful explosion in the solar system. Solar flare is an energetic burst of light and particles triggered by the release of magnetic energy on the Sun. It appears as a sudden intense brightening region on the Sun, typically lasting several minutes to hours. Coronal mass ejections, CMEs, often accompany large flares. It usually occurs in the vicinity of active regions or sunspots, on the dividing line between areas of opposite magnetic polarity. The primary energy source of flares is the tearing and reconnection of strong magnetic fields. Solar flares are by far the most powerful explosions in the solar system, with energy releases comparable to billions of hydrogen bombs. Solar flares release immense amounts of energy and result in electromagnetic emissions spanning the spectrum from gamma rays to radio waves. Traveling at the speed of light, these emissions only take 8 minutes to reach Earth, rapidly affecting the dayside. Flare in Earth. This image was captured by NASA's Solar Dynamics Observatory, SDO, and shows a blend of light from the 17.1 and 13.1 nanometers wavelengths. The Earth is shown to scale. The flare is classified as an X2.2 class flare on March 11, 2015. An active region rotated into view and sputtered with numerous small flares and towering magnetic field lines that stretched out many times the diameter of Earth, May 23, 2018. In different wavelengths. These SDO images from 7:25 p.m. Eastern Standard Time on February 24, 2014, show the first moments of an X4.9 class flare in different wavelengths in angstrom of light, seen as the bright spot that appears on the left limb of the Sun. Hot solar material can be seen hovering above the active region in the Sun's atmosphere, the corona. Classification. Scientists classify solar flares according to their brightness in the X-ray wavelengths from 0.1 to 0.8 nanometers, 1 to 8 angstroms. X-rays are continually emitted from the Sun. Detecting significant increases in the intensity of those X-rays can provide an early warning of a solar storm. 2GOES, Geostationary Operational Environmental Satellite, spacecrafts in geosynchronous orbit record solar X-ray emission. The modern scale or rating system for solar flares uses the letters A, B, C, M, and X, according to the peak flux in watts per square meter of soft X-rays. Class subdivisions. Also, each class has 9 subdivisions ranging from 1.0 to 9.9 in a logarithmic scale. It means you could have a C2.3, an M6.5, or an X9.7 event. Even though X is the highest level, the numbers don't stop at X9.9. On October 28, 2003 there was an X17.2 flare followed several days later by an approximately X28 flare on November 4th. It was so powerful that it overloaded the sensors measuring it. The sensors cut out at X28. These were the biggest flares ever measured. Usually it takes 3 days for the solar storm to reach Earth. However, the storm in 2003 took only 19 hours. Class comparison. A is the lowest level. B is 10 times more powerful than A. C is 10 times more powerful than B, 100 times than A. M is 10 times more powerful than C, 1000 times than A. X is 10 times stronger than M. This makes an X event 10,000 times stronger than A. A flare in 5 different colorized wavelengths. NASA's Solar Dynamics Observatory captured these images of an X 2.7 class flare, as seen in the bright flash on the left, on May 5, 2015. Each image shows a different wavelength of extreme ultraviolet light that highlights a different temperature of material on the Sun. By comparing different images, scientists can better understand the movement of solar matter and energy during a flare. Impacts. The explosive heat of a solar flare can't make it all the way to our globe, but the electromagnetic radiation, primarily X-rays, and energetic particles, mainly high-energy protons, produced are dangerous to living organisms. On the surface of the Earth, we are well protected from the effects of solar flares by the Earth's magnetic field and atmosphere. However, solar flares can temporarily alter the ionosphere or upper atmospheres, disabling satellites, scrambling aircraft navigation, and interrupting high-frequency radio communications for hours. Finally, even at their worst, the solar flares are not physically capable of destroying Earth.